Hello, let us look at some factoring questions. Here comes the first one, 12x squared minus 5x minus 3. So first, what we have to do is we have to look at the common factor out of these three. What is the common factor? Oh, we don't have anything. So then in that case, we get to multiply the first coefficient, the leading coefficient, to the constant term at the end. And we get to realize that that's equal to negative 36. So now you're looking at which two numbers multiply to negative 36 but add to negative 5. All right, oh, wait a minute. 9 and 5 works because 9 and 4 works because 9 and 4 multiply to 36, but difference between those two is 5. To make that into negative 5, we should have negative 5 and positive 4. Then we know that this expression is equal to 12x squared minus 9x plus 4x minus 3. So as you can see, I'm just rewriting negative 5x into these two terms. Now then, I can combine the first two terms and then second two terms, meaning find the common factor between the first two terms. Then we end up getting 3x is common. Then we get to realize 4x minus 3 is the other factor. Now when I look at the last two terms, then I realize that that's exactly what it is. So I can just rewrite it in this way. Then I realize that 4x minus 3 is common in both terms. So we get to factor 4x minus 3. Then remaining term, which is 3x plus 1, becomes my the other factor. So in fact, this expression is a factored form of the original given question. All right, let's look at the second one. So we have something similar in this way. So 9x squared plus 30x plus 25. Now I can do this question number 2 in the same way as number 1, but when you think about 9 times 25, it's a pretty large number. In fact, it's 225. So in case if you feel comfortable and then see the numbers that are rather multiplied to that number and add up to 30, which some of you guys might have the idea already, you can do it that way. But this question was a little bit interesting because this is a perfect square, which is 3x quantity squared, and then 25 is 5 squared. Oh, then since the first and the last term is perfect square, I'm thinking about this. If I have a plus b squared, we know that to be equal to a squared plus 2ab plus b squared. That's what we end up getting. Now, we notice that if the given expression here matches this perfect square expansion, then our factored form must be same thing as this. So let's see if 9x squared plus 30x plus 25 matches this one. So we realize the first two terms, the first term and the last term, is perfect square as we have seen. The middle term has to be 2 times of the product of those two. So it's the middle term plus 2 times of the product of these two, which is 3x and then 5. Let's look at it. 3x times 2 becomes 6x. 6x times 5 is 30. It matches. So since I know that this is a perfect square expansion, I can simply rewrite this expression in this format I have here, which is the first term, which is 3x, plus the last term, which is 5 square. All right. How about the next one? So in this case, it looks like a difference of perfect cube. So if I had to rewrite it, it would have been x cubed. Or maybe let me use different letters here. A cubed minus b cubed can be expressed as a minus b, the same expression as they are, and then a squared plus ab. Notice that this sign is opposite of that one, plus b squared, and this is always positive. Following this factored structure, so we end up rewriting this one as 2x cubed, 2x quantity cubed, that's 8x cubed, minus 3 cubed. I understand you don't have to write in this manner. Some of you guys might have this one already in your mind, but I just wrote it so that we can compare. Now, my first part of the factoring is a minus b, meaning writing down as they are. So we have 2x minus 3. Second part is in this way. First one square, so we get 2x quantity square plus product of those two, 2x times 3. And then the last one is 3 square. Then we end up getting 2x minus 3. The second expression is 4x squared plus 6x plus 9. That becomes our final answer. All right, let's look at the next one. Number 4. As you can see, we have x minus 3 is common. It was actually totally intentional. So if you had to rewrite this one as a, it might be a bit easier for us to look at it. Let a is equal to x minus 3. Then you get to see that this expression can be a squared plus 3a minus 10. Now you know that this is much easier for you to factor because which two numbers multiply to negative 10 but add to 3? It's 5 and negative 2. So we get a plus 5 times a minus 2. But of course, a is a variable that I just made up just to make it look a bit simpler. So I have to submit x minus 3 in place of x's, in place of a's. So we get x minus 3 plus 5, and then x minus 3 minus 2. Then we end up getting x minus 3 plus 5 becomes x plus 2. And then the other one becomes x minus 5. That becomes my final answer. Alright, so this was a quick review on factoring, and I'll see you later.